GraphRAG exists because normal retrieval is bad at one very specific type of question, and once you see the failure, it's hard to unsee. Regular RAG chops your documents into chunks, turns each chunk into a vector, and when you ask something, it grabs the handful of chunks that sound most similar to your question. That works fine when the answer lives in one paragraph. Ask what the refund window is for enterprise accounts, and it finds the right page. But ask what the main complaints are across last quarter's support tickets, and the whole thing quietly falls over. There is no single chunk that holds that answer. The answer is spread across 40,000 tickets, and the system only ever reads about 10 of them. Microsoft Research put a name on this. They call it a sense-making question, or a global question, and their paper is called From Local to Global. It came out in April 2024, the code went public on GitHub that July, and the whole thing sits under an MIT license. What makes the failure worse is that regular RAG doesn't tell you it failed. It confidently returns 4 chunks that happen to match the wording of your question, then writes a summary that sounds complete. You get a real-looking answer built from a tiny slice of the data. The fix starts with something that sounds almost too simple. Instead of just embedding your text, you send every chunk to a language model and ask it to pull out the things in that chunk and how they connect. So if a chunk mentions that a chip company was acquired by a larger firm in 2016 and now makes low-power processors for wearables, the model writes down both companies as separate entries, plus a short description of each, plus the relationship between them and how strong it is. Do that across every chunk in your corpus, and you end up with thousands of these little fragments. There's a detail in the paper that a lot of people skip, and it's one of my favorite parts. The size of your chunks changes how much the model actually notices. When Microsoft ran extraction with 600 token chunks versus 2,400 token chunks, the smaller chunks pulled out almost twice as many entity references. The model just gets lazy on long text. So they added a trick where after the first pass, they feed the extracted list back to the model and basically say, you missed things, find them. They call it gleaning. It runs a few rounds, and it lets you use bigger chunks without losing quality. Small design choice, big effect on cost. All those fragments then get merged into one graph. Every time the same entity shows up in different documents, those mentions collapse into a single node, and every repeated relationship becomes a heavier edge. And the papers test on a set of podcast transcripts that produced roughly 8,500 nodes and about 20,000 connections. This merging step is also where most homemade versions break. If your data calls the same company 3 different names and your matching is just checking whether the strings are identical, you now have 3 separate nodes that should have been 1. That's the quiet failure mode nobody warns you about. Now the part that actually makes GraphRAG different. Once you have the graph, an algorithm called Leiden looks at it and finds clusters, groups of nodes that are tightly connected to each other and loosely connected to everything else. Think about your own workplace. There's an official org chart, and then there's the real one, the people who actually talk to each other every day. Community detection finds the real one, and it does this in layers. At the top level, you might get 30 or so big clusters covering the whole dataset. Go one level down, and those split into hundreds of smaller ones. Keep going, and you reach clusters that can't be split any further. Every one of those clusters then gets written up as a report by the model, and it builds from the bottom up. Small clusters get summarized first. Then those summaries feed into the summary of the bigger cluster above them, all the way to the top. What you're left with is a layered description of your entire dataset, written before anyone asked a single question. And that on its own is useful. You can scroll through the top-level summaries to see the broad themes, spot something interesting, then drop into a lower level to read the detail. It's like getting a table of contents for data that never had one. When a question finally comes in, GraphRAG uses those summaries in a map-reduce pattern. It shuffles the community reports, splits them into batches, and answers your question against every batch in parallel. Each partial answer also gets a self-assigned usefulness score from 0 to 100, and anything scoring 0 gets thrown out. The surviving answers get sorted by that score, packed into one final context, and reduced into a single response. Every part of your dataset gets a vote, which is the exact thing plain vector search can never do. The numbers are solid, but not magic. Against standard vector RAG, GraphRAG won on comprehensiveness between 72 and 83% of the time, and won on diversity of perspective between 62 and 82%. And here's the honest part, which I appreciate that they published. On a fourth measure, directness, plain vector RAG won. Its answers were shorter and more to the point. On a fifth measure about helping the reader make an informed judgment, the two basically tied. So this isn't a universal upgrade, it's a trade. You get breadth and coverage, you give up crispness. The token math is where it gets interesting for anyone paying a bill. Answering a global question by just summarizing all your source text works, but it's brutally expensive because you're pushing the entire corpus through the model every time. Using the top-level community summaries instead gets you competitive answers using around 2 to 3% of those tokens. That's the real argument. You pay a lot once at indexing, and then every global question after that is cheap. There's another finding buried in the appendix that surprised me. They tested 8,000, 16,000, 32,000, and 64,000 token context windows, and the smallest one won. Stuffing more into the window made answers worse, not better. Querying comes in a few flavors. Local search is for questions about one specific thing, so it pulls that entity's neighbors and the raw text behind them. Global search is the map-reduce path for big-picture questions. And then there's drift, which stands for dynamic reasoning and inference with flexible traversal. Drift starts wide, uses the community summaries to orient itself, generates its own follow-up questions, then dives into the specific parts of the graph that look promising. It's closer to how a person actually researches something. You skim to get your bearings, then you zoom in. Cost is the reason a lot of teams looked at this and walked away. Indexing that 1 million token podcast dataset took 281 minutes of processing. That's a small dataset. Early on, someone reported spending around $33,000 just to index a 5 GB legal collection before answering a single question. Microsoft's own repo carries a warning telling you indexing is expensive and to start small. They're also clear that this is a demonstration of a method, not an officially supported product. Microsoft knew this was the blocker and shipped an answer called LazyGraphRAG. Instead of summarizing everything up front, it does almost nothing at indexing time and defers the expensive work until you actually ask something. Their claim is that indexing costs the same as plain vector search, which works out to about 0.1% of full GraphRAG, while matching global search quality at a fraction of the query cost. So the choice now isn't graph or no graph. It's how much you pre-compute versus how much you compute on demand. If your data changes constantly, or you only ask a few questions, Lazy wins. If you have a stable corpus and thousands of daily queries, paying once upfront still makes sense. Where this shows up in real work is mostly places where relationships are the answer. Legal teams tracing obligations across contracts that reference other contracts. Compliance work where you need to show which documents produced a conclusion, not just trust the output. Fraud and risk, where the whole point is connections between people and accounts. Medical research, pulling threads across thousands of papers. And there's a regulatory angle too, because a graph gives you an audit trail. You can point at the specific entities and relationships behind an answer, which is getting harder to do without, as explainability rules tighten in Europe. Where it doesn't make sense is worth saying plainly. If your users ask lookup questions all day, this is expensive overkill, and vector search will be faster and better. If your documents are already structured, a database query beats all of this. And if you skip the prompt tuning step, your extraction quality will be mediocre because the default prompts pull out generic things like people and places, which is useless in a specialized domain. The project sits around 34,000 stars on GitHub with version 3.1 released in May 2026, and the ideas have spread well past Microsoft's own repo into LangChain, Llama Index, Neo4j, and others. What sticks with me isn't the tooling, it's the reframe. Your documents were always a network. Chunking and embedding just hid that from you, and this puts it back.